OK, now that we have the intro section out of the way, we can start talking about individual attacks. So what we'll do in this unit is we'll start at the lowest level and work our way up to higher layers. So today, we'll first start by talking about different types of network attackers. And then we'll see 3 different protocols at lower layers and think about possible attacks on them. So that's kind of the plan for today. So before we start talking about attacks, let's talk about what type of attackers exist on the network. At least for this class, we'll focus on 3 types of attackers. And what makes them different is what capabilities they have. So first, we have the man-in-the-middle attacker. You might have seen this term when we talked about cryptography. And it's the same kind of attacker. This attacker can modify or delete your packets. They can read what your packets say as they're being sent across the network. And they can also create packets of their own and send those across the network. So that's the man-in-the-middle attacker. Then we have the on-path attacker. This is someone who is not able to modify or delete your packets. That's why there's no check mark here. But they are able to read your packets. And they can also send packets of their own. And finally, we have the off-path attacker. This is someone who cannot modify your packets. They also can't read your packets. But they can still create malicious packets of their own. So something that all 3 attackers have in common is the fact that they can all create their own malicious packets. And this has to do with the fact that on the internet, anybody can send and receive packets of their own. That's why everybody has the ability to create their own packets. There is no restriction on who can send packets. But in addition to being able to create packets, the on-path and man-in-the-middle attackers have extra capabilities. So we'll think about all 3 attackers as we go through various protocols. Now, because we mentioned that anybody can send their own packets, one attack you can already do is something called spoofing. So far, when we've shown packets being sent, we've always shown the packets being filled in honestly. For example, if I'm sending a message to Bob, I will always write my IP address as the source address. But what if someone chose to lie? So what if Mallory sends a message, and instead of writing in the header that the message came from Mallory, she writes that the message is from Alice? Now, that's not actually true. The message is being sent by Mallory, but she's lying about the source address so that the message looks like it's coming from Alice when it's actually coming from Mallory. This type of attack is called spoofing, and all that it is lying about who is sending the packet. And everybody is able to spoof packets. Any of our computers are able to send data into the internet. And when our computer creates a packet, nothing is stopping us from changing what the header says. So that's an attack that everybody can do. And we'll see how spoofing can help us make some attacks possible as we go through specific protocols. So one question you might have at this point is why we chose this specific threat model. Why did we model an on-path attacker as someone who can read but not modify messages? Is this someone we're going to encounter in real life? So it turns out the reason why we chose these specific attack models is because they correspond to attackers that you see in real life. So for example, and you don't have to remember these details, this is why we chose to model an on-path attacker, because in real life, there are some devices out there that you can use to snoop and see what packets are being sent on a wire. So I don't know how these work either, really, but you can imagine having some sort of device, and you clamp it on a wire, and it can read the voltage levels and tell you what data is being sent over the wire. So this is an example of someone who might be an on-path attacker. That's why we chose the model that we did. Other examples of on-path attackers, here are some divers who went down into the underwater cables that carry internet data between continents, and they somehow installed a listening device so that they could see what packets were being sent. So that's another example of an on-path attacker. Now, one more example of an on-path attacker that doesn't involve divers might be your computer itself. So for example, when we had one of these network topologies where everybody is connected using a single wire, the result is that if any of the hosts send a message, it gets sent on this wire, and everybody can see it. So for example, if A wants to send a message to C, A is going to signal that message along this wire, changing the voltage on this wire, and C is going to see that message, but so are B and D. Now, technically, what's supposed to happen is that B and D are supposed to look at the header, realize that they are not the intended recipient, and ignore the message that's being sent. However, if B or D are malicious, they could see that the message is not meant for them and still listen anyway, and that could be one way that B and D become on-path attackers because they can listen to what's being sent on the network. So that's an example of an attacker that might be on-path. Now, if you are an on-path attacker, there are various tools you can use to analyze the packets that you're receiving. So we won't use these in this class, but there are these utilities that exist out there that can take a sequence of ones and zeros and actually make them look nice so that the attacker can try to read what the packets are saying and maybe try and figure out what you're trying to do on the internet.